Good morning. Oh, I'm sorry. Good morning. My name is John Kowalski. I'm part of the marketing team here at Gardner, and welcome to Office Hours. Today we'll be talking about physical testing and field testing with Senior Application Specialist, Mr. Corey Cohen. We are recording this, and tomorrow morning with our follow-ups, we'll send you the presentation you're about to see, as well as a link to the recording for your further review. And also, if you have questions during this time, please enter them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them following the brief presentation. If you're unfamiliar with the Office Hours format, it's a shortened presentation, maybe 20, 25 minutes, and then it's open to you for your questions, for discussion, to talk through any challenges you may be having at your facility. We have a lot of experts on the phone in addition to our presenter, so lots of knowledge here to help you. So with that, let me turn things over to Corey. There you go, sir.
Thank you, Mr. Kowalski, and good afternoon, everybody, or morning, depending on where you're joining us from. So today's topic is physical testing and field testing. So today I'll just be going over a few of the tools, the simple tools that can be used to test your coatings and whatnot. Not going to get too far into the technical weeds, not going to get too much into the theory. But of course, once we reach the question and answer session, if you want to go more in depth into any one of these instruments or topics that I cover, feel free to ask and we can delve deeper. All right, first up, we're going to talk about fineness of grind gauges. So this is a tool that can help you determine the size of your grind when you're, say, dispersing pigments or something, or any sort of solid into a liquid, and you want to know what your particle size is. This instrument, the Hegman gauge, or the fineness of grind gauge, as it's called, is going to tell you the size of the largest particles that you have in your mixture. And the way it works is you have this, it's a metal block with a sort of canal down the middle. You can sort of see from the side view that canal gets deeper and deeper as you go. So it starts out very shallow and gets deeper, and the idea is you put a dollop of your coating or your liquid in the shallow end, and then there's a scraper, a flat scraper that you use to, the liquid goes into the deep end, not the shallow end, the deep end. Then you take your scraper and you scrape the liquid up towards the shallow end. And at a certain point, once the depth of that canal gets smaller than the largest particles in that mixture, you're going to start seeing those particles dragging on the coating, as you can sort of see from this the top view diagram here, where there's sort of lines here in the coating. And so where that line begins, right about here, that indicates the largest particle size that you have in that liquid. So here we would rate this at about 4 Hegmans, or about 50 microns. It's just a simple tool for telling the size of your particles in your liquid. That brings us to density cups. Density cups are useful for certain liquids, colorants, bases. It can be useful to have the density of your liquid so that you can measure it out in using a scale, which is of course more precise than measuring it by volume. So once you have the density of your liquid, you can convert volume to weight and more precisely measure out your materials. And so the way a density cup works is it has a defined volume. We have various ones. We have 50 and 100 milliliter. Those are the metric versions. We also have US versions, which come in either 83.2 milliliter for the regular cup, or for the so-called midget cup, it's a tenth of that, 8.32 milliliters, and it's sized that way for a particular purpose. So the way these work, this example here you're seeing on the bottom is the regular US density cup. And what you do is you take that cup, you would take the cup and the top, that little lid that you see here, put that on your scale and tare it. So you want to zero it out so that you're not weighing the cup itself. You only want to weigh the liquid inside the cup. So once you've done that, you then fill the cup with your liquid. You put the lid on top of it, and there's a little hole in the center of the lid that's going to squeeze out the excess liquid. And then you can just wipe it off the top. And the purpose of that is you really want to have this cup filled with a well-defined volume, an exact volume of liquid, in order to get the most precise, the most accurate measure of your density possible. And so by having that hole in the top of the lid that allows you to squeeze out the excess liquid, you're left with a cup that's filled precisely to a certain volume. And then that volume of liquid is weighed in grams. And for the US density cup that has a volume of 83.2 milliliters, all you do is you take the weight of the liquid in grams, you move the decimal over 1, divided by 10, and you get the density of the liquid in pounds per gallon. That's why it's that exact volume, 83.2 milliliters, because that conversion works out perfectly when it's that volume. Okay, and then we have film thickness gauges. There are a few different types of film thickness gauges. This is for measuring the thickness of your coating. So we'll begin with wet film thickness gauges. These are for measuring the thickness of your coating while it's still wet, while it hasn't been dried or cured yet. And there are two options for that. One is called a comb type gauge. That's what you see here on the right. The other is called a interchemical gauge, or IC gauge. That's the one you're seeing on the left. So beginning with the comb type gauge, the way this one works is that gauge has different teeth on it that have different gaps. When you press that gauge down onto a flat surface, those teeth have different gaps between the gauge and the substrate. So you press that into your wet film, and you'll look for the tooth with the biggest gap that has made contact with that wet coating. So here the comb type gauge has been dipped down into the coating, and then you lift it up, and we see here that the coating has made contact with the 75 micron tooth, but not the 100 micron tooth. So we know that the wet film thickness is between 75 and 100 microns. So this is sort of a rough tool for just sort of very roughly measuring the thickness of your wet film. And then we have the interchemical gauge, or the wet film wheel, as it's commonly called. And this is a bit more precise. And the way this works, the measurement principle isn't too different from the comb type gauge, but instead of having different teeth of defined gaps, what you have is this sort of canal that goes all the way around this wheel, and that canal, the depth changes continuously around this wheel. So what you do is you roll it through your coating, and you can see here that the coating is not making contact with the center part of that wheel yet. And then here, once we get to 50 microns, that is where the coating makes contact. So you just continue rolling this through, rolling the wheel through your wet coating, and when you get to the end, when you've rolled it all the way through, you're going to take a look at that center canal, that divot of a certain depth, and you're going to find on the scale, on the wheel on the outside, where the coating has made contact. So in this case, we would see that the coating had made contact at the 50 micron mark, And so we know that the wet film thickness in this case is 50 microns. And you'll notice that it's the same scale on both sides. And it's just sort of a double scale, so you can roll it all the way through and you get two measurements rather than one, just so you can take two measurements and average them and sort of get a more precise reading that way. Okay, next up for film thickness measurement is destructive film thickness measurement. So this is for dry films, dry coatings, whereas before we were measuring coatings in their wet form. Now we're measuring fully cured coatings. And sometimes, depending on the substrate that coating has been applied on, it's necessary to sometimes destroy the coating in order to measure it. And so that's what this device is for. This is called the biko cut. The way this works is this tool has different cutters of sort of V-shaped cutters of defined angles. There are three standard cutters it comes with, 45 degrees, 26.5 degrees, and 5.8 degrees. And so that makes, you run that through your dry film, your dry coating, and it makes a V-shaped cut in the surface. And because it's V-shaped, you can sort of look down onto the coating through a microscope and see the horizontal width of the coating that you're trying to measure. You can see that in this image here. Say you're trying to measure the film thickness of this brown coating. You would measure the width using a microscope, and then using the known defined cutting angle, you can convert the width into a depth. And so this is how you measure film thickness destructively. And that brings us to non-destructive methods, what's also often referred to as just a dry film thickness gauge, or DFT gauge. There are two basic types of gauges. One that uses an eddy current measurement principle for measuring on non-ferrous substrates, and then another one that uses a magnetic inductive method for ferrous substrates. Ferrous substrates are just materials that contain iron. Fe is the chemical symbol for iron. And so typically, not always, but typically anything containing iron is going to be magnetic, and thus this magnetic induction principle can be used to measure the film thickness. And so for these types of tests, we have our biko test film gauge. And we have two types. We have the biko test and the biko test light. The biko test full version can do a number of different things, such as air temperature, relative humidity, and calculation of dew point from those things. There's a calibration mode specifically for SSPC, the Society for Protective Coatings, something like that. There's a particular calibration method they specify for dry film thickness gauges, and so this version, the biko test full version, can accommodate that. And it also has things like screen flip. If you're working with the unit sideways, it'll automatically flip the screen for you. You can do 0, single, and 2-point calibrations. Very strong wear-resistant tip, so this instrument will last you a while, and a host of other features in this unit. And then we also have the light version, as mentioned, so it doesn't have quite as many features as the full version. It doesn't do the humidity and temperature measurement, but it still does do both ferrous and non-ferrous film thickness measurements. So of course that means that you can measure the thickness of coatings as long as it is over a metal surface, either a ferrous or non-ferrous metal substrate. So this one also does the screen flip for ease of use, easy one-hand operation. It has that same wear-resistant ruby probe tip, so it's going to last you a good while. This one only does 0-point calibrations and a few other features as well. All right, and then we're going to talk a little about viscosity. So one sort of quick and easy way to measure viscosity is to use flow cups. And the idea here is that you have a cup with a defined geometry and volume, and then you have an orifice in the bottom of this cup of a defined diameter. And so what you do is you fill these cups with your liquid up to the very, very top. And there are two types here. There are the cups you see at the top here, that fit onto a stand, and you would use a glass plate to fill it all the way up to the top, and then use the glass plate to keep that liquid in place until you're ready to start the test. Or you have these dip cups, which are a little bit easier and quicker to use, and these you just sort of dip into your liquid, lift it up, and then start timing. And so the idea here is that you're measuring the amount of time it takes for the liquid to flow out of the bottom of the cup, and that the amount of time it takes is directly related to the kinematic viscosity. So higher viscosity liquids are going to take a longer time to flow out of the bottom, and thinner liquids, less viscous liquids, will take a shorter time. So you measure the amount of time it takes for the liquid to flow out the bottom of the cup, and that's known as the efflux time. And then for each cup, there's a calculation where you take the efflux time, plug it into an equation, you will get the kinematic viscosity in centistokes. And for somewhat more precise viscosity measurement, we have also rotational viscometers. And the idea is you take a container full of your liquid and you stick a spindle, down into the liquid, and the spindle spins through the liquid. And from the resistance that that spindle experiences, that spindle is of course connected to the viscometer, which is causing it to spin, and also measuring the torque, the resistance on that spindle as it spins due to the viscosity of the liquid. So the more torque experienced by that spindle as you spin through, the more resistance it's feeling, the higher the viscosity of the liquid. And so this can be used to measure viscosity in centipoise. So whereas before with those cups, it's measuring the kinematic viscosity in centistokes, and that has to do not just with the viscosity of the liquid, but also with the density of the liquid. So with the cups, the density of the liquid comes into play when measuring viscosity. This test, the rotational viscometers are independent of the density, and so the unit is in centipoise rather than centistokes. Okay, and that takes us to our field test kit. So a field test kit is a kit that contains a number of tools that a painter might take out into the field to test conditions to make sure that conditions are right for painting. And so one of the things that's often included in one of these field test kits is the dry film thickness gauge, like the biko test that we saw before for measuring dry film thickness non-destructively. In addition to that, a field test kit might include a moisture meter. So these are used to verify the moisture content of your substrate to determine if it's ready to be coated. For example, let's say you lay down some concrete that then needs to be painted. Well, the concrete has to be dry enough first. If it's too wet, the paint isn't going to apply correctly. So you need to make sure that the moisture content of that concrete has dropped low enough that you're able to paint it, for example. So it determines the correct drying and curing of raw materials, works with most building materials such as wood, plaster, masonry, gypsum, and concrete. It has a backlit display for easy reading under poor lighting conditions, built-in electrode pins, which are replaceable, and it can also do air temperature measurement. Next in our field test kit would be a thermo anemometer. And this is a tool that can measure the air temperature, air velocity, and relative humidity. It helps to determine if ambient conditions are right for painting. If it's too hot out or too cold out, that might not be the right conditions for applying your coating. And so this can tell you whether those conditions are right. It can also, based on the relative humidity and temperature measurements, it can calculate the dew point temperature. And this is made of impact-resistant materials. They're fairly hardy, so if you should, drop them in the field or whatever, they should just keep on kicking. And then lastly, we have our infrared thermometer, the T200. This can measure the temperature of surfaces to be coated to make sure, again, they're not too hot or too cold. It has laser targeting, which shows the precise location of the temperature measurement, max and min recording, over range indicator. So you can set your tolerance and it'll automatically tell you whether the temperature is too high for coating. You can select degrees Celsius or degrees Fahrenheit. Again, this has a drop resistant construction. So these are durable tools for using out in the field. Also nice for telling whether your brisket is done when you're using your smoker, so that's good too. And that was all I had for you today. So now we will turn it back over to John Kowalski for our question and answer session.
Great, thank you, Corey. And yes, definitely handy for checking that brisket. For sure. So if anyone has any questions, please log them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them. In addition to Corey, we have several members of our field sales team and business line management team on the line to help and assist with any questions you may have. So Corey, while we're waiting for some folks to log their questions in, are there frequent questions that you get from customers on, just basic field testing protocols or standards that, every organization should adhere to?
You think I'd be ready for that question because you ask it every week. I guess one thing, one thing we get inquiries about a lot, just in general, sort of, is when it comes to standards. So, of course, in order to calibrate an instrument or verify the calibration on the instrument, what you use is a standard of a defined, whatever it is you're measuring. So, for example, when measuring film thickness, dry film thickness, using one of those biko test gauges for non-destructive dry film thickness measurement, this type of standards that you would use for that to verify that the calibration is good, or you can use it for the 2-point calibration, so you can calibrate at several different points. They're called shims. So these are just little flat plastic pieces of a well-defined thickness that you can place over a metal substrate and take a measurement and make sure that your instrument is reading correctly. So, for example, if you have a 50 micron shim, so that means that shim is exactly 50 microns thick within a certain tolerance, and you can place that over your metal plate and take a measurement to see whether it's accurate. And again, it can be used for the calibration. So during a single point or a 2-point calibration, if you're using that 50 micron shim and the meter comes up at 55 microns, you could then adjust that value to adjust the calibration curve of the instrument so that it's measuring better. So Having defined standards is very important for verifying the accuracy of your instruments. And it's also important to treat those standards well, because those shims, especially the very thin ones, can be fairly fragile, and you want to avoid creasing them or bending them or doing anything to them that might affect the thickness value you would get off of them, because that would make them useless, and you'd have to get new shims.
Mm-hmm. Okay. Yeah, definitely it makes sense. And I suppose too, just the way you go about your testing in terms of I guess direction, amount of pressure you put on it, that all takes goes into developing a standard protocol for running these tests, correct?
Yeah, of course. One of the phrases that you'll hear us use a lot, I'm pretty sure we mention it at least once every web seminar, is apples to apples. You always want your measurements to be apples to apples, meaning everything from using the correct instrument. If you're going to compare measurements between two instruments, you want to make sure you're using the same, at least the same type of instrument. Even better is to use the exact same instrument model. So that's very important. But even down to, as John mentioned, the amount of pressure you're applying on the instrument, the angle at which you're taking it, or the orientation of the instrument, every little thing. It's surprising how many tiny little things can affect your measurements in minute ways. And so as much as possible, you always want to keep your measurement parameters, your measurement procedure as consistent as possible.
Yeah, and that's even from operator to operator, making sure everyone does things exactly the same way. Then you're, getting that apples to apples comparison Corey mentioned. What else? It looks like we got another question coming in. I know we get some questions regarding conversion between the different viscosity cups. I don't know if you care to elaborate on some of those questions we get regarding those conversions? And I know we do have a poster for that as well. So if anyone would like one, please, don't reach out to us. We'll hook you up. I know people.
That's what I was going to mention. We do have a viscosity poster. It's just a big chart that shows you conversions from the measurement time, the efflux time, from one cup to another. So this is specifically for those flow cups and dip cups for those quick viscosity measurements. But those cups come in a number of different models and a number of different sizes for different ranges of viscosity. But so if you have, one lab that took a measurement using the number 3 cup and another lab that took a measurement using a number 4 cup, there is a way to convert the reading from one to a reading from the other. And if that's of interest to you, please reach out to us. We have a free viscosity poster that we can send to you that will give you those conversions.
Mm-hmm. Great. Not a lot of questions. So, I encourage you, if you have any questions, please reach out. Looks like we just got one in here from Vivek. Can you talk about any instruments you have that provide more than one measurement? For example, viscosity, density, and temperature, a bonus for surface tension. Do we have anything like that, Corey?
Most of these physical test instruments are sort of one and done instruments. They're only going to typically measure one property. We have seen a number of instruments like the thermo anemometer or the film thickness gauge, the biko test, that can do temperature and humidity as well as dry film thickness. But when it comes to physical test equipment, they're basically single-purpose instruments for the most part. If you're talking about our optical instruments, our color and appearance instruments, that's where we do combine a few different measurement principles into one. We have a new gauge that measures, a new color instrument that measures color, gloss, and reflectivity and topography for texture analysis. We have other instruments that can measure color and gloss, fluorescence, color and gloss. But when it comes to physical tests, they're more or less single purpose, typically.
Unless the biko test that you mentioned, the humidity and film thickness and all that stuff. Mm-hmm. Let's see, what else here? Okay, I just got a message in. The chart, the poster, it's called the conversion chart, has all the manual viscosity conversions. So, that's something if you'd like to get your hands on that during our follow-up email that's coming tomorrow morning with the link to the recording of this as well as the presentation Corey just walked through. Just hit reply. It'll come to us in marketing, and we'll hook you up with one of those posters. No problem at all. So other questions out there from anyone are you experiencing something at your own facility, a certain challenge that we can assist with? We have a lot of experts on the line and would love to help in any way we can. If any of the members from the field team or the business line team want to jump in, feel free to unmute yourself or pay me to unmute you. And are there frequent questions you guys get when it comes to physical testing and field testing? Let's see here. And also, please be on the lookout, too. We will be switching from our WebEx webinar platform in about a month. So you'll see our normal invites go out. That'll take you to a link to register. It'll look a little different, but we're hoping that system's a little easier than WebEx. Another question in here, any data loggers? Example, temperature cycling during storage.
So we do have temperature loggers that will log the temperature of, or they're designed at least for logging temperature of products that are baked in an oven after being coated, automobiles or powder coatings, things that after being coated need to be run through an oven to be cured. And so these temperature loggers have probes that you can attach to different parts to monitor the temperature of those parts during that baking process and make sure that the coating is properly cured at the end of it. I'm not sure exactly what you mean by temperature cycling during storage. If you'd like to maybe elaborate on that,
yeah.
We can see if we can get an answer.
Yeah, Vivek, I'm going to unmute you here. Are you there? You're unmuted.
Can you hear me?
Yes, we can.
Yeah. I
Welcome.
Thank you. Nice presentation, by the way. Thank you.
Thank you.
I'm not that familiar with the BYK. I've heard of it, but I'm not that familiar with having used it. But yeah, so we have needs for products that we occasionally have complaints on, and we're wondering if we look at it in the lab and we don't have any idea, but we suspect it's the conditions they're stored at, maybe 6 months, a year, with night to day temperature cycling. We can look at the temperature conditions there, or we can just wondered if there's some way we can actually physically log it. So it's just a thought. I mean, I really, well, I guess what I'm, and I will peruse your website, but what we're looking for is integrated instrumentation, right? So we appreciate you got a lot of very good manually usable instrumentation. We're looking for something a little more automated.
Yeah, so unfortunately, our loggers are really designed more for shorter term use. I mean, they can work for up to 24 hours or so, depending on the sampling interval. But they are battery operated. It's not something that can be used to run continuously for days or weeks at a time. I will say that an application like this actually did come up maybe a couple of years ago where somebody was looking to use it for that use, and we just couldn't make it work. It really is designed specifically for kind of shorter bakes and for monitoring temperatures within ovens and not so much long-term monitoring. So unfortunately, I'd have to say no, we don't have anything that would work for that.
Yeah, that's fair. That's fair. Yeah, I do like your handheld viscosity meters and and moisture sensors and so forth. Very useful. So we'll keep an eye on it and see if we can acquire some.
Good. Is this the first webinar of ours that you've joined?
I believe so. I believe so. Yes.
Well, welcome. We run these office hours where they're more of an informal discussion at least once a month, and then we sprinkle it with maybe another 2 or 3 more formal webinars or presentations that we do throughout the month. So you'll be sure to get those invites from now on. And we also made a note too, because you're kind of new to the BIC family. We're going to drop one of our catalogs in the mail to you. It just goes through the whole product breadth and a good overview of a lot of different things. So we'll get that in the mail to you. So look for that coming in the next week or so.
Great. Thank you. That would be great.
You bet. Thank you. And I'll put you on mute here again, unless you have any other questions.
No, that's it. I need to look at your website a little more. I'll wait for that catalog too. Thank you.
All right. You're welcome. You're welcome. Okay. Other questions out there, folks? How can we assist? Let's see if there's any more that came in here. Let's see. Anyone from the field team? What are you guys seeing out there? What questions are you getting regarding testing? Both physical testing and field testing. Quiet group today. Anything else you want to add, Corey, that you want to elaborate on a little bit more? Jonathan Bain, one of our sales people. Jonathan, are you there, sir?
Can you hear me?
Yeah, yes, we can. How are you?
Yeah. I'm doing well, thank you. I just wanted to chime in real quick. Yes, we see, with regard to physical test, the basics, the pendulum, the abrasion testers, all these things, all the things you covered in the presentation with regard to the testing kit. Those are, primary instruments that people are using. But here recently, over the last couple of years, the surface tension that the gentleman referenced earlier is also something we see, and we address that with the PGX goniometer, little pocket goniometer. It's not as exact as the larger, way more expensive surface tension units, but it does give some good data that is usable. It is what it is what it is compared to the larger versions. So that's nothing really changes from that front with regard to especially in the coatings industries. Everybody's got pretty much the same needs. Data logger with the oven recorders that Corey had mentioned. The temp guard is basically the equivalent, or actually it's a little bit better, but people tend to call them data packs, but we also do that as well. So from a coating standpoint, we're a one-stop shop with regard to physical testing, just as we are with color and appearance. So that's what I had to say. Thank you.
Awesome. You bet. Thanks, John. Another question here too, Corey, or someone more technical than I. Can you speak about the calibration? Keeping our instruments calibrated and validating measurements to like NIST standards, etc.
So yeah, of course, keeping your instruments calibrated is important for the ones that can undergo a calibration, like the film thickness gauges. So of course, every calibration is going to be different depending on the type of instrument. The film thickness gauges I've talked about, you can calibrate using shims to get multiple point calibration if you have the right unit for that. The 0 point calibration, which we saw, is done on a metal plate. So the way these film thickness gauges actually work is it's essentially just measuring the distance between the probe, between the bottom of the probe and the instrument and the metal substrate. And whatever space is between is the coating. So if it's measuring the distance between the substrate and the probe tip, what it's actually measuring is the thickness of the coating itself. And so one recommendation we actually have for that, even though these dry film thickness gauges do typically come with a metal plate, both a ferrous metal plate and a non-ferrous one for doing a 0 calibration on, it's actually better to calibrate those instruments with the substrate that you'll actually be using. So if you're painting a metal part, it's actually best to do a 0 calibration on the metal part itself before it's coated, and that's going to give you the most accurate readings on that substrate. And that just has to do with different alloys, different mixtures of metals that are used to create different types of steels and whatnot, and that can affect the readings. And so it's always best to do a 0 point calibration on the actual substrate you'll be using. So yeah, there are different types of calibration depending on the instrument. If you take, for example, the the viscosity cups, those flow cups, or say the density cups, there's no real calibration you can do with that. A calibration means that you're actually adjusting the instrument so that it will measure more accurately. But of course, when you have a tool that's basically just a metal cup, there's really no calibration for it, but you can still do calibration checks. And that's very important as well, because it can tell you when your tool might have worn out, or maybe it was dropped and damaged and it's not reading accurately anymore. So even if you can't actually calibrate your instrument, it is important to do regular calibration checks. And for something like a viscosity cup, you would use, or any type of viscometer really, whether it's a rotational viscometer, a cat viscometer, or a viscosity cup, a dip cup, or a flow cup. What you can do is use a standard oil. There are various oils we sell at different viscosity levels, and those oils are certified. They come with a certificate traceable to some standard organization, possibly NIST. I'd have to check exactly what it is, but those oils can be used to test the viscosity or test the accuracy of your viscosity measuring tools. So you can use take a measurement of the viscosity of the oil, the standard oil, using your flow cup, say, and make sure that the reading you get matches with what's printed on the certificate to within a certain tolerance. Yes, both calibrations and calibration checks are important to do regularly to make sure that your tools are measuring accurately.
Great. Thank you, Corey. One last thing, unless we have some more questions in too. I know part of physical testing, we have drawdown machines, both manual and automatic. Do you want to say a couple words about those, Corey? The benefits of each of those and how those are used?
Yeah. So we do have. a few different automatic drawdown machines for doing drawdowns of your coatings on a chart or other type of substrate. And so, of course, you can do drawdowns by hand using just a chart and a clipboard and a drawdown bar or a wire wound rod. But this, of course, goes back to that apples to apples thing where different people doing drawdowns, even if they're using all the same materials, all the same tools, different people will apply different amounts of pressure during the drawdown. We'll use different speeds when drawing down. And so different operators can often get different results when drawing down your material. And of course, typically the purpose of doing a drawdown is you want to measure your coating. You want to measure the color, you want to measure the gloss, or some other property in a uniform, consistent way. And so, of course, in order to get accurate, consistent, precise results, you want the drawdowns to be as consistent as possible. And so this is where the automatic drawdown machines come in, where you can use a weight so that it's exerting the same amount of pressure on the drawdown bar every time. You can set the speed so that it's doing the same speed every time. These come in both vacuum plate versions where you can hook up a vacuum pump, or some of them actually have built-in vacuum pumps for holding your chart onto the surface. They also come in a clipboard version. We have different levels that can do different speeds, can accommodate different sizes of charts. So really whatever your needs are as far as drawdowns, we most likely have an automatic film applicator that can work for you. And it really is better to do it that way just for the consistency of your readings, so that you know when you do two drawdowns and you measure a gloss difference between the two, you know that it's an actual gloss difference and not just a difference because of the way that the drawdown is performed.
Yeah. Are you seeing, I took over control from you, Corey, sorry about that, but I wanted to share the webpage to show these.
Yeah, these are our, on the left, our biko drive unit, which we actually have a new version of that coming out. I think it's already out, actually, called the Biko Drive S. So that has a few more features. And on the right, we have our Biko Drive XL, which is the larger one. It can accommodate larger substrates. It has a few more options as far as speed controls and things like that.
Yeah, then the manual.
Yep, and these are applicators for manual drawdowns. We have a number of different types. The top left, just a basic drawdown bar, which is just a metal bar with a defined gap for the coating to flow under, so you get a consistent film thickness. And then we have other bars that have multiple clearances, multiple gaps. For example, the square one, sort of towards the bottom middle with that yellow drawdown. That one actually has 8 different gaps, and it's enclosed. So if you're doing maybe thinner liquids, that one might be better because it's not going to flow outwards like it might with one of the bars that's not enclosed. So again, a ton of different options for applicators depending on what your exact needs and your materials are. Excellent.
Excellent. Well, we appreciate the time today, Corey, and the expertise. I know this is a lot of stuff, and you have to know a lot about a lot. So we thank you. And thank you, everyone, for attending today. Hope you learned something. As I mentioned, we'll send you the presentation as well as a link to the recording of this tomorrow morning. If you have any questions at all, hit reply to that email, and we'll get it to the right people, or contact your local regional sales manager, inside sales manager, or give Corey a call in technical service, and he can assist. Also a great resource is the website bic-instruments.com. You can go to the physical properties section and look around, a lot of options there. So With that, thank you. Enjoy the rest of your day, and we look forward to seeing you on a future Vic Gardner web seminar. Thank you.
Thanks, everyone. Have a good day.